Last time we learned how to solve a system of equations by graphing. Today we're going to solve a system of equations by substitution. Here's how you would do that. First, you want to solve one of the equations for one of the variables, either x or y. Doesn't really matter which, just do whichever is going to be easier. Step 2, substitute the expression from step 1 into the other equation, and you're going to solve for that variable. From there, you'll know one of them, either x or y. You're then going to substitute that answer into either original equation, and that's going to allow you to solve for the other variable. Remember that in a system, our solution is going to be a point, an ordered pair, so that means I need an x and a y. And always remember to check your solution. All right, we'll be doing these two problems on paper, so go grab some. Before I solve the actual system, imagine for a second I gave you the equations 2x minus 3y equals 16, and I also told you that x equals 4. Well, if I know x equals 4, then I can substitute 4 in for the x in the other equation. Then I would have 2 times 4 minus 3y equals 16. And then I would be able to solve this equation for y. It's pretty much the same idea for solving a system. First step is I want to solve one of the equations for one of the variables, but luckily on this one, I already have that. This equation is solved for x. Since it's solved for x, I can take what x equals, 3y plus 11, and substitute that in for the x in the other equation. Just like I did over here, if x is 4, I can replace the x with the 4. If x equals 3y plus 11, I can replace x with 3y plus 11. So I will write 2, and then instead of x, I'm substituting in this expression, 3y plus 11. And it must be in parentheses because you will have to distribute. And then I'm just going to write the rest of this equation. 2x minus 3y equals 16. And now I'm going to solve this equation for y. Distribute 6y plus 22 minus 3y equals 16. I then want to solve this equation for y, so I'm going to combine the like terms that are on the same sides. We just combine them together. 6y's minus 3y's is 3y's. Subtract 22 on both sides. 3y equals 6, negative 6. Divide both sides by 3, and y equals a negative 2. But we're not done, because remember, a system has a solution that's an ordered pair, x and y. Right now I only have y, I need to figure out x. So to find x, I can take this answer and substitute it back into either of the original equations. It does not matter which one you choose, it's up to you, and usually when it's your choice, we want to go with the one that's easier, and that's going to be this one. So I'm going to substitute y is negative 2 into this equation. So I have x equals 3 times negative 2 plus 11. X equals negative 6 plus 11, and 11 minus 6 is going to be 5. So my final answer, which I'm going to write as an ordered pair, is 5, negative 2. How do I check those solutions? Just like I showed you last video, I'm going to substitute my answer back into both equations and make sure it makes both of them true. So the first equation was 2x, so 2, and I'll replace x with 5, minus 3y, I'll replace y with negative 2, equals 16. So 10, negative times a negative, positive 6. Does 10 plus 6 equals 16? Yes. So that one's good. Let's check the other equation. X equals 3y plus 11. X, which is 5, equals 3y, negative 2, plus 11. 5 equals negative 6 plus 11. That's also true. They're both true, which means I have the correct answer. Let's try the next one. So on this one, I don't have an equation already solved for a variable. So I have to pick one equation with a variable that's easy to solve for. So looking at this, which variable do you think is going to be the easiest to get by itself? Probably going to be this y. The reason I'm going to pick this y is because it's the only variable without a coefficient. If I were to solve for x or this y, I would have to divide. And we divide, sometimes we end up with some nasty fractions. And since most of you in the class are not fans of fractions, we're going to try to avoid that, and I'm going to solve this equation for y. So I'm going to write that over here and solve it for y by subtracting 2x on both sides and getting y equals a negative 2x plus 2. Now that I have an equation solved for y, I can take what y equals and substitute it into the other equation for y. Really important, don't take this and plug it back into this equation because then you've not used this one at all. I've rewritten the first equation, I have to plug it into the second equation. I'm replacing y with what y equals. So I have 5x minus 3 times negative 2x plus 2 equals negative 28. Simplify the left side. Be careful that you are distributing a negative 3 here, not just a 3. Negative times a negative is plus 6x minus 6 equals negative 28. Combine the like terms. 11x minus 6 equals negative 28. Add 6 on both sides. 11x equals negative 22. Divide by 11, and I get x equals negative 2. Am I done? No. Remember, my answer has to be an ordered pair. I have x, I still have to find y. So I'm going to take that answer and plug it into one of the original equations. I think the first one looks easier, so that's the one I'm going to use. 2x plus y equals 2. So 2x plus y equals 2. Replace x with negative 2. 2 times negative 2 is negative 4. Add 4 on both sides, and y equals 6. So my final answer is negative 2, 6. And again, you could verify your answer by plugging it back into both original equations and making sure both equations become true. Make sure to insert a picture of your work into this, Make sure to insert a picture of your work into the notebook. Make sure to insert a picture of your work into the notebook.